Okay, now we're going to go into the Pythagorean Theorem, which is kind of like a second part of 7.1. These are problems that are from your notebook. So we've got the Pythagorean Theorem written up there, and we have a right triangle drawn. So Pythagorean Theorem only works for right triangles. Okay. So, on this one it says, draw a triangle that represents the following problem and then solve the problem. If the base of the triangle is 15 and the hypotenuse is 39, what is the height of the triangle? So if we draw a triangle here, right triangle, and then we have the base is 15, and using the word hypotenuse indicates right triangle because right triangles are the only ones that have a hypotenuse. And so we've got that, and then the hypotenuse is the long side, that's C. Then what we can do here is we can say 15 squared plus b squared, which is our height on here. I know it seems counterintuitive because we got base and height, is equal to 39 squared. So 15 squared is equal to 225, so we're going to subtract 225 from both sides. And we get b squared is equal to 39 squared minus 225. Is equal to 1,296. Then we're going to take the square root. And in the case of the triangle, you know, in the past when we've taken the square root of a number, we've done the plus or minus. But with triangles, the sides that we're solving for are lengths, and so it's always going to be the positive square root. So then we get the answer of, let's go ahead and simplify 1296 down. So this is 2 and then 6, 48. This would give us, we can do 2 again, and 3, 24, 2 and 162, 2 and 81, and then we know 81 is 3 to the 4th power. So this is the square root of 2 to the 4th power times 3 to the 4th power, which then that means we're going to divide these by 2. So this ends up being 2 squared times 3 squared, which is 4 times 9, so 36. So that's again how we can use our information from before of simplifying radicals to be able to get our answer instead of plugging it into our calculator. And that's great. If it ends up being a perfect square, then that's perfect. That will work great. But if it isn't, we want to be able to simplify it down into its exact form where it has the whole number and then also times the radical. Okay, so on this next problem, it says, if you are 23 feet from the bottom of a 65-foot tree, how far are you from the top of the tree? So if we draw this, we know that this is where you would be at. This is the top of the tree. And so how far you are from the top of the tree would be the hypotenuse. So we're trying to solve for C in this case. So you're 23 feet from the bottom, and it's 65 feet tall. So our Pythagorean theorem would be 23 squared plus 65 squared is equal to C squared. So 23 squared plus 65 squared is equal to 4,754. So C is going to be equal to the square root of 4,754. So again, we want to try breaking this down. So this is 2 times 2,377. Then from here, if you keep trying to find out numbers that go into 2,377, you actually figure out it's a prime. So this doesn't actually factor down any farther. So we actually have 2 times 2,377. And again, these are exponents of 1. 1 divided by 2 isn't going to give us a whole number. So this radical does not simplify. So we would keep it as the square root of 4,754 if we wanted to keep it in exact form. But if it was to give us kind of an idea of what that represents, we would go ahead and plug that into our calculator. So the square root of 4,754, and we would get the decimal approximation of 68.95 feet as our answer. Okay, so again, I just want to make sure you understand the difference. If the problem ever asks for it in exact form, you have to leave it in its simplified radical form. And the square root of 4,754 is as simplified as it gets because it factors to two primes. But if it doesn't ask for the exact form, or a lot of times in word problems, it makes more sense to give the decimal approximation because radical form doesn't make a lot of sense in application. We would go ahead and plug it into our calculator and simplify it that way. All right, so this is a couple more problems of examples of using the Pythagorean Theorem. Again, if a picture isn't drawn for you, you want to draw a picture of it. A kite is stuck at the top of a tree, so you got a tree. And then we have 90 feet of string let out. And you are 15 feet from the bottom. I know this isn't drawn to scale, but it gives us an idea of what's going on here. So in this case, we're trying to solve for b, how tall is the tree? So this means we have 15 squared plus b squared is equal to 90 squared. So we want to subtract 225 again because that's what 15 squared is equal to. And so we get b squared is equal to 90 squared minus 225. So we get 7,875. Again, we're going to be doing b is equal to the square root of 7,875. So again, we want to practice simplifying the radical. So first we're going to go ahead and divide by 25 because it ends in 75. So 7,875 divided by 25 is equal to 315. So this is 5 and 5. Then we know this one is divisible by 5 because 315 divided by, it ends in a 5. So we're going to divide that by 5 and we get 63. This would be 7 times 9, which is 2 and 2. So we could rewrite this as the square root of 5 to the third power times 2 to the second times 7. And so then when we go ahead and divide every exponent by 2, we're going to end up with 5 to the first power on the outside and 5 on the inside. 2 to the first power on the outside because 2 divided by 2 is 1. 0 remainder, so no 2's on the inside. And then times 7 on the inside because there's, 1 divided by 2 isn't going to give us a whole number. So then this gives us the answer of 10 square roots of 35 in its simplified form. Again, if we want to figure out what that is as an approximation, we go ahead and just do 10 times the square root of 35. Which would be 10 times 5.92, which would give us the answer of 59.2 feet. Okay, now this problem here is actually probably going to be more important because this is actually setting up polynomials in this case. So what we have is when we set up the Pythagorean theorem, x squared plus 2 squared is equal to x plus 2 squared. So remember, this right side is a perfect square trinomial because we're squaring a binomial by itself. So that ends up being the first term squared plus 2 times the first number times the second number, so times 2 times x, plus the second number squared, so 4. So this is equal to x squared plus 4x plus 4. And then we have x squared plus 4. Okay, so now we're going to get everything to one side. So we get 0 is equal to 4x, which in this case tells us x is equal to 0. So honestly, that really doesn't make a lot of sense because you wouldn't have a triangle. So when we solve for this, we would say that it's not no triangle or not possible. And my handwriting's really bad today. Okay, so these aren't the ones that are in your book, but here are other examples where we can also set this up. So if the base of the triangle is 27 and the hypotenuse is 45, what is the height? So again, this is going to give us 27 squared plus b squared is equal to 45 squared. We subtract 27 squared from both sides. So we get b squared is equal to 45 squared minus 27 squared, which is equal to 1,296. So we're looking at b is equal to the square root of 1,296. So we can start factoring this out. Let's go ahead and just divide this by 3, and we get 3 times 432. Divide this by 2. And we get 216, and then we know that 216 is equal to 6 to the third. We already worked on that. And 6 to the third is equal to 2 to the third times 3 to the third, because we can factor out the 6. So we're looking at the square root of 2 to the 4th power, because we have 1, 2 times 2 to the third, times 3 to the 4th power. So we go ahead and divide each of these exponents by 2, and we get 2 squared times 3 squared, which is equal to 4 times 3, or 39. Okay, if a ladder is 15 feet long and is placed so that the bottom is 3 feet from a building, so here's the building, here's the bottom of the ladder, it's 3 feet, and it's basically tilting here. This is 15. How high is it? So we're trying to find our b value here. So we would do 3 squared plus b squared is equal to 15 squared. So we subtract 9 from basically 125. So, sorry, not 125, 225. 15 squared is 225. Minus 9. And so we get b squared is equal to 216. So we're looking at b is equal to the square root of 216, which we know is equal to 6 cubed. So we'll go ahead and divide by 2, and so we're going to get 6 and the square root of 6, because 2 goes into 3 one whole time with a remainder of 1. So 6 square roots of 6, and then if we want to find an approximation of that, we can do 6 times the square root of 6, and that gives us 2.45, which is equal to 14.7. So we would say it's 14.7, not 17. 14.7 feet high. Okay, then finally, here's one other example in terms of a word problem that's a little more wordy. Okay, so 2 friends are rock climbing. One is holding the guide rope and has announced that 36 feet is let out. They want to know if the friend climbing is taking as the friend climbing is taking a break, how high up she is. The friend on the ground is 15 feet from the base of the cliff. How can we figure out the height? What is the height? So we've got the cliff, and then we got the friend up at this point right here. And then we have the other friend down here, and this friend is 15 feet. The rope is what's connecting them, and we're going to pretend like this is the one where it's not right now attached to a pulley, or that the friend is at a pulley. No, we're going to pretend like this person is basically holding on a rope right there, connecting them. So this is 36 feet, and so we're trying to figure out the b value here, the height. So again, we have 15 squared plus b squared is equal to 36 squared. minus the 225 from both sides. So we get b squared is equal to 36 squared minus 225, which is 1071. So b is equal to the square root of 1071. So we want to try factoring this out. 1071 is divisible by 3. So this is 3 times 357, which is again divisible by 3. So this is 3 times 119, which is divisible by 7. So this is 7 and 17. So this is equal to the square root of 3 squared times 7 times 17, which then again, when we simplify this, is 3 square roots of 7 times 17, or 3 times 119. So that's what it would be in exact form. And then when we want to find the decimal approximation, we just do 3 times the square root of 119, which is going to give us the answer of 32.73 feet.